Let's solve the following quadratic inequality. The first thing you want to do is find what's called the critical points. So we're going to factor the left-hand side, and we get the two critical points. Now, for finding the critical points, these are boundaries where the shading is going to start and stop. So we're going to use an equals sign because we don't care about the shading yet. We're just finding the critical points. So we see that the critical points are -3 and -2. When you put those on the number line, now we start to worry about what the shading is. And when we look back at the inequality right here, we see that it's a greater than or equal to, which means that these boundaries are going to be solid dots. So I'll draw them in solid there. Now there are three regions, region 1, region 2, and region 3. And the best thing to do is just to test all three regions. So what we're going to do is we're going to look at our original inequality. So x squared plus 5x plus 6 is greater than or equal to 0. So we'll write that down right here. And what you're going to do is test points in each region. So in region 1, let's test x is equal to -4. And what I mean by test is you plug it into this original inequality. And what do we have here? So we're trying to determine, this is a question mark, if this is true. So this is 16 minus 20 plus 6, and that's -4 plus 6. Let me scoot the screen up. Then what we have is 2 is greater than or equal to 0. Okay, that's true. So we know then that we're going to, whoa, let's undo that. Oops, I don't know how to undo that. Let's not undo that. So what we're going to do is we're going to shade region 1 because that came out true. And that was our first thing. Now let's move that back up out of the way. And what we're going to do is we're going to test region 2. So this is a capital 2. And what we're going to do is test x equals, I need some value that's in between those two. So the only thing I can test, really, it looks like I'm going to do -2.5 in that region. So let's do x equals -2.5. And really, all we need to do is determine if, when you plug it in, it comes out greater than or equal to 0. So you don't actually have to do this all the way out, although maybe I should. Plus 5 times -2.5 plus 6, and we're trying to determine if that's greater than or equal to 0. So what do we have here? So if we have 2.5 squared, that's 6.25. That's positive. Then 5 times 2.5 is now -12.5 plus 6. Oops, I keep drawing that line up there. Oh goodness, I don't know how these things get so... okay. There we go. Okay, then what do we have? 6.25 minus 12.5 plus 6. And that's a -0.25 is greater than or equal to 0. And that's not true. So what that means is don't shade region 2. Okay, so then let's move this stuff up. Oh goodness, I don't know why that one's not moving, but we'll just move it all up. Move that all up. Okay, so going back, this is what we have. We've got -3, and that region was shaded, -2, and we're not going to shade right there. So then let's just test the last one. We're going to test region 3. And what I'm going to do is test x equals 0. So we have 0 squared plus 5 times 0 plus 6 is greater than or equal to 0. What we see is 6 is greater than 0. So since that's true, we're going to shade the third region. So what we see is our answer in interval notation will be negative infinity up to negative 3. This is a bracket because those are solid dots on the boundary. And then negative 2 to infinity. All right.